Hello, everyone. We'll get started in just a few minutes. All right, let's get started. Welcome to our webinar today. My name is Justin D'Souza. I'm a quantitative specialist here at Statistical Solutions. During today's webinar, we are going to discuss the selecting of statistical analyses. So we'll break it down into several categories. We'll look at predictive analyses, correlational, tests of differences. So I will go through the entire presentation first, and if you have questions, I will be doing a question and answer session at the end of the webinar. So if you have any questions, you can type those into the chat box or the question and answer box. My colleague Melissa will also be assisting with questions as well. So if you have questions about the services that our company provides, Melissa can answer those questions for you via the chat box. We will be sending a copy of the recording as well as a copy of the presentation, most likely tomorrow. So just let us know if you have any questions. All right. So today I will be starting out with a brief overview of services that our company, Statistical Solutions, provides. Then we will dive into the topic for today and discuss the selection of statistical analyses. I'll give a brief demonstration in Intellectus and the decision tree that we have in our software that can help you to select an appropriate analysis. We'll then conclude with a summary and a question and answer session. So the first couple slides of the presentation, I have a list of links that will provide a list of the previous webinars that we've conducted. So that will be in the webinar archive, and future webinars that we will be doing upcoming next month. So for determining your research questions and figuring out the appropriate analysis, it's important to lay the foundation with level of measurement. So there are three distinct types of levels of measurements for variables, and the selection of what type of variable is really going to help a lot for deciding what analysis you should run. We have continuous, nominal, and ordinal variables. A continuous variable is a variable that falls on a continuum, so it can fall on a range of values. Examples of these include test scores, so SAT scores or ACT scores, GPA, an exam score. Those are all considered continuous. Temperature, whether it's measured in Fahrenheit or Celsius, is considered ratio, which is often considered to be a continuous variable. We also have weight, which could be in kilograms or in pounds. and composite scores from a validated instrument. So if you're using a survey tool like the job satisfaction survey or the ProQOL for quality of life or the leadership factor questionnaire, you most likely have to develop composite scores, and this is done by taking an average of the Likert scale questions in your survey. So once you take an average or a sum of ordinal Likert scale questions, that resulting variable is continuous. So that will allow you to use parametric statistics, and we'll discuss those more in the next slides. A nominal variable is a variable that has distinct, discrete categories, but it does not follow an intrinsic order. So something like gender, you have male, female, and you have other groups. There's no hierarchy to this variable. You have discrete possibilities. Same as ethnicity or race, white, Black, Asian, Hispanic, other. You have discrete categories and there's no order or ranking to them. Passing and failing of an exam, same concept. There's no overlap, you can't pass and fail. So maybe you code 1 as pass and 0 as fail. That is a dichotomous variable because there are only 2 possibilities. An ordinal variable is a subset of a nominal variable, but the difference is your variable can now be ranked. So examples of this include education or an ordinal item on a survey. Education, some researchers see it as nominal, some see it as ordinal. I tend to see it as ordinal because there's a natural progression. High school, associates, bachelor's, master's, doctorate. So it goes up a ladder and it's categorical. So I would consider it to be ordinal. Ordinal item on a survey is something like a Likert scale. So strongly agree down to strongly disagree. That would be an example of an ordinal variable from 1 to 5. So before you even begin developing your research questions or determining what analysis you want to pick, make sure that you can assign one of these variable types to every variable you intend to use. And need to fall into one of these categories, and then you can decide what analysis is best to address your question. So on this slide, we have a series of examples for correlation tests. Correlation is a two-way association, so you don't have an independent or dependent variable necessarily. You just have 2 variables of interest. So notice that I've identified variable 1 and variable 2. There's no independent, dependent language or predictor and criterion language. We just have 2 variables of interest. And depending on the level of measurement of the 2 variables, you're going to use a different test. We can see for the first example here, is there a relationship between self-esteem and self-efficacy? Now, assuming that we're using a Likert scale-based survey and we're creating composite scores from that survey, we can assume that these are both continuous variables, in which case you can use a Pearson correlation. So Pearson correlation is a parametric test that tests for differences or tests for the relationship between 2 continuous variables. When you do a Pearson correlation, you probably need to check for normality as well. So you need to make sure that self-esteem and self-efficacy follow a bell-shaped distribution. And there are many ways to do that. You could do it with a histogram. You could do it with a Shapiro-Wilk test or a Kolmogorov-Smirnov test. You need to make sure that normality is supported when you run a Pearson correlation. If it's not, then you may want to consider running a Spearman correlation as a backup. So a Spearman correlation is a non-parametric analysis, and it's used when you have You're testing the relationship between two variables when at least one of them is ordinal. Remember how I mentioned ordinal variables? An example of that is education, because it falls in a hierarchy. So in this second example, we have education and self-esteem, and we want to see the association between those two. Education is ordinal and self-esteem is continuous. So you would run a Spearman correlation. Another example that would use a Spearman is if you have education and income bracket. So say income bracket, you give someone a multiple choice question and they have to identify their income through a range of values. So maybe 30,000 to 40,000, 40,000, 50,000. You're not getting a specific dollar amount, but a range of values in a multiple choice format. Then you would have two ordinal variables in this example, education and income bracket, which would lead to a Spearman correlation. So the two examples here for Spearman correlations both have ordinal variables in them. But as I said earlier, when you check for normality, say you propose a Pearson correlation and normality is not supported. So you run a test of normality and it's not met. Then as a backup, many researchers run a Spearman correlation. So a Spearman is considered the non-parametric version of a Pearson correlation. Now, when you have a dichotomous variable and a continuous variable, such as gender and self-esteem, you can run a point biserial correlation. When you have two nominal variables, so something like gender and ethnicity, you can run a chi-square test of independence. Okay, so this is the correlation test family. These are the primary examples I see. There may be a few other ones. There is a way that you can control for variables, so you can introduce a third variable and you can control for it, and that's called a partial correlation, I believe. So there are some alternatives. There's even, instead of a Spearman correlation, some people use a Kendall's tau. So depending on the literature, you may have alternative options. The next test family to look at is a predictive relationship or predictive design. So when you have a predictive design, you now do have independent and dependent variables. And in a predictive design, these predictors, the independent variable is usually called a predictor, and the dependent variable is called a criterion variable. Now, the predictors can be any level of measurement. It doesn't matter what they are. You can have continuous, ordinal, or nominal. You can have one predictor. You can have multiple predictors. The outcome is what is going to determine what regression model you use. So if you have a continuous dependent variable, so what you're trying to predict, if that variable is continuous, such as self-esteem here, then you use a linear regression. So a linear regression has an outcome that is continuous in nature. You have an outcome that is dichotomous, such as passing and failing of an exam, then you can use a binary logistic regression. Binary is the key word there, meaning two-level outcome. Passing and failing is it's dichotomous. You have two possibilities. There's no third possibility. Then we have a multinomial logistic regression, which is used when your outcome has more than two possibilities. So ethnicity, white, Black, Asian, Hispanic, that has at least three possibilities. So you can't use a binary logistic regression. You have to use a multinomial. And the final predictive type is a ordinal logistic regression. So remember, we talked about income bracket. If you use the multiple choice question for income bracket, then that is an ordinal variable, in which case you use an ordinal logistic regression. So I didn't even pinpoint in these examples, as I was just describing them, I didn't pinpoint what the predictors were because it really doesn't matter. You can have any variable type as your predictor. It's really your outcome criterion variable that is the most important. Okay, and that will help pick what regression model to use. So under this test family, there are some more advanced techniques such as mediation and moderation and structural equation modeling. But those are more advanced steps. And once you understand the essential techniques in these tests, you can then consider doing mediation, moderation, structural equation modeling, things like that. Okay, the next test family we have is looking for differences between variables. So looking for differences, this may be under a experimental design or quasi-experimental design. Sometimes it's called causal comparative design. This is where you're looking for differences between distinct groups. So if you have a comparison of two groups, for example, is there a difference in self-esteem between males and females? If self-esteem is a continuous variable, which it is in this case, then you can use an independent sample t-test. T-test is going to be a two-group comparison, males versus females. If we take that example and expand on it and use self-esteem again, but instead use ethnicity, ethnicity has more than two possibilities. So you use an analysis of variance, ANOVA for short. You can then look at multiple dependent variables at once. So differences in self-esteem and self-efficacy. So not just self-esteem, we've added self-efficacy as well. And we're still looking at ethnicities. This would be a multivariate analysis of variance, or a MANOVA for short. The M stands for multivariate, which means you have multiple dependent variables. So that's what this means right here, multiple continuous dependent variables. Now, in the event that the assumptions of normality are not met for these variables, then these last two options here are the non-parametric alternatives. So a Mann-Whitney U-test is used in two scenarios. It's used either when you try to do an independent t-test and self-esteem, for example, does not meet normal distribution. If self-esteem doesn't follow a bell-shaped curve, then you can run a Mann-Whitney U-test instead to look at the difference in self-esteem between males and females. A Mann-Whitney U can also be used to look at the difference between an ordinal variable by two groups. Okay, so education level or income bracket between males and females, you could do a Mann-Whitney U-test. A Kruskal-Wallis test also has two examples in which you can use it. You can use it when you propose an ANOVA. So if you propose an ANOVA and the assumption of normality is not met for self-esteem in this example, if it's not met for your dependent variable, then you can run a Kruskal-Wallis test as a non-parametric backup. The second occurrence in which you can use it is if you're using an ordinal dependent variable. So again, education level or income bracket based on ethnicity, you can use a Kruskal-Wallis test in this example. So instead of looking at differences by group, you can also do a longitudinal study in which you're testing for differences over time. So generally, when this is done, an intervention has been applied. So maybe you do a pre-test or a baseline. You administer an education or intervention to improve performance. And then you run a post-test with the same participants to see if there's been a noticeable change. If you just have a pre and post, and you're using a continuous variable, then you can do a dependent sample t-test. If you have 3 or more time points, so instead of just pre-test and post-test, you have pre-test, post-test, follow-up. That would be 3 different time points with the same sample. It's really important to note that same participants need to be taking the pre-test, post-test, and follow-up. So there needs to be a way that you match them. Maybe it's through an ID number, or they pick a letter from a hat. You need to assign a identifier to the participants so you can match their scores. So if you have 3 points in time of comparison, then you do a repeated measures ANOVA. And then we get to the non-parametric alternatives. So again, for a Wilcoxon-Sign rank test, there are 2 scenarios in which you can use this. The first being if you try to do a dependent sample t-test and job satisfaction does not meet the normal assumption, so it's not following a bell-shaped curve, you can then run a Wilcoxon-Sign rank test. The second time that happens is when you can test for differences between ordinal variables. So is there a difference in income bracket, for example, between pre-test and post-test? That would be an example of a time to use a Wilcoxon-Sign rank. A Friedman ANOVA also has 2 possibilities of use. The first being if you propose a repeated measures ANOVA and job satisfaction does not meet the normality assumption, you can then run a Friedman ANOVA. The second occurrence to use this test is if you have an ordinal variable that you're looking for differences over time. Very similar to the previous example of pre-test, post-test, but we're introducing a 3rd time point. And you could even add more time points. It's not constrained to 3. You could have 5, 6, 7 different follow-ups. Now, perhaps the most complicated analysis here is merging of the difference of group and time. So this is a true experimental design where you've potentially randomly assigned participants to treatment and control groups. And you're also looking for differences between pre-test and post-test. This is when a mixed model ANOVA is used. There are 3 moving parts here. You have differences over time, pre-test and post-test. You have differences by group, which would be treatment and control, or experimental and control. And then you have the interaction effect. Interaction is looking for differences by time and by group. So you have pre-test treatment, pre-test control, post-test treatment, post-test control. The interaction effect is looking for differences between those 4 possibilities. Okay. All right, so in summary, before you start looking at your research questions, first look at your variables. Create a table of all your variables of interest and establish the relationships you're trying to build. And then pinpoint what level of measurement are the variables that you're proposing to use. Are they nominal, ordinal, or continuous? Then you want to pinpoint, are you looking at a 2-way association or a 2-way relationship, which would mean you can use correlations? Are you trying to predict an outcome, which would require a regression model? Are you looking at tests of differences between groups? So do you have discrete groups and you want to look at differences between them? Or are you looking at tests of differences over time? So more longitudinal design. You can then use the Intellectus statistics decision tree to help guide your decision. So let me open Intellectus here, which is our company's software. So Intellectus is a software that we have developed that can crunch your numbers. So you can do data management in here, very similar to SPSS. And you can remove outliers, you can compute data, you can reverse code, you can do all the common procedures used to clean data. And then you can actually run the analysis. So I'll give you a brief demo of that. Some methodology information, more catered to this presentation. I think the decision tree is going to be very useful if you don't know what analysis you need to run. So the decision tree, you can see how it's kind of organized, how I organize the slides in the presentation. So you can predict an outcome, you can look for differences between groups, you can explore for associations or relationships, test for differences over time. So the idea is that you can start the tree. Maybe you have an idea, I want to predict an outcome. Is that outcome scale, nominal, or ordinal? Say it's scale. So you can see it goes down the decision tree and it's pinpointed. You need to run a linear regression for this example. So explore for differences between groups. Do you have more than one dependent variable? Yes. Do you have any covariates? No. And you can see it's gone down the path. We have multiple dependent variables, so we need to run a multivariate analysis of variance, a MANOVA. So once you've pinpointed what analysis you're going to run, you can then go into data analysis plans. And this is typically what would go in your methodology chapter. So say we select a linear regression. Intellectus will give you an example of a sample research question and the hypotheses. And then it's going to go through the essentials of a regression model. What is a regression model? It gives a definition. What does the model equation look like? What assumptions need to be verified, like normality and checking for outliers and absence of multicollinearity. And then it goes through the interpretation of the regression model and the typical things you need to interpret, followed by citations at the bottom. So this is usually a section in the methodology called data analysis plans. So you would just input this information there. So we have a lot of the data analysis plans. We have tests between groups, like a t-test. We have ANOVAs, non-parametric tests, the ones I covered today, Mann-Whitney test or Kruskal-Willis test. We also have power analyses in here. So if you're trying to figure out what is the minimum sample size I need to target for my research, you can use this tool. So for example, say we're doing a linear regression again. With one predictor, you can change the number of predictors you have. With one predictor, a linear regression with a medium effect size requires 55 participants. With a large effect size, it's 25, and with a small effect size, it skyrockets to 395. So we do have webinars on power analysis, but just really briefly, if you don't have prior literature to say what effect size you need to use, go with a medium effect size and use the middle option. Okay, so under analyses, we also have several different tests you can run. So you could do, just to show an example here, this data set is, each row is a different car model. So we have some different statistics on these models, the miles per gallon, the horsepower, the weight. So let's see whether horsepower and weight of the car, I think this is in tons, metric tons, predicts miles per gallon. So I'll go to analyses, linear regression is what we're going to run. The dependent variable will be miles per gallon. Independent variable, let's do weight and horsepower. You can go to options at the top right here and you can see what assumptions are being verified. So normality is being checked and homoscedasticity being verified. Click calculate. And just like magic, it's going to give you an APA write-up of these results. Okay, so you can see normality is checked with a QQ plot, homoscedasticity is checked with a residuals plot, multicollinearity is checked with BIF. So it gives you an APA write-up and it gives you interpretations. You can hover your mouse over figures and it will tell you more information about those figures. Then it gives you an overall interpretation. So what were the results of the regression here? So based on this finding down here, collectively, we have a predictive relationship between weight, horsepower, and mileage. As we dive inside the table, we can see that weight on its own is significant. So a p-value below indicates a significant result. And based on the significance, we can then look at the beta value here, which tells us that as weight increases, the mileage is decreasing. Okay, so with every 1 ton increase in weight, the mileage of the car decreases by 3.88 miles per gallon. It's quite a lot. And then horsepower is also significant. And it shows that with every 1 unit increase in the horsepower, the mileage decreases by 0.03 gallons. Okay, so just a brief demonstration of Intellectus. Let us know if you have any questions about the software. I'll now open up the panel to questions. And I just want to reiterate, I don't think I mentioned this at the beginning, but our company helps with every part of the dissertation. So if you've hit a roadblock, we have methodologist specialists and we have literature review specialists for both quantitative and qualitative studies. So we can help you develop research questions, figure out your research design, pinpoint a theoretical framework, help you determine what analyses you need to run, and actually assist with the analysis itself. So we can use SPSS or we can use Intellectus. We have lots of options for crunching the numbers. So I'll now open the panel to questions. If you have any, you can type those into the chat box or the Q&A box. And we are going to send everyone a copy of the recording of today's session and a copy of the presentation itself. All right, do we have any questions? All right, we have a question from Sandra. How do you avoid the ease of plagiarism with cutting and pasting the write-ups? That's a great question. So first of all, there are only so many ways to write up regressions and t-tests and statistical analyses. It's been done every way possible up to this point. So that's something to consider, is that when you report it, you're really reporting it in APA format. What I've highlighted here are examples of like reporting things strictly in APA format. But given this, when you have citations, things like this is where you want to try and rephrase, change the order of the sentences, use synonyms, try to use different verbiage to describe those statements. So it's a little mixture of both. You know, there is going to be a match if you put it in a plagiarism software, because there are only so many ways to phrase statistical results. Been done for 50 years now of articles that are online. So that's quite difficult to avoid, but you can rephrase things when it's possible. You know, if you have a citation, or you can even invert the order of the sentence, you know, where that's possible, flip where the comma is, try to rephrase where possible. But for the results chapter specifically, it's not something I see committees come down hard on. So I wouldn't worry too much about plagiarism in the results. Okay, we have a question from Rachel. If I want to look at the relationship between an independent variable and a dependent variable in a cross-sectional study with participants at the same time point but at different stages of treatment, how would I go about doing that analysis? So it seems like your sample is just participants who are experiencing chemotherapy. So you said cycle 1 versus cycle 6. Do the cycles in the middle matter? 2, 3, 4, 5? I don't think it really matters. It's still cross-sectional, but you have to define that in your sampling. The participants can come from any cycle of chemotherapy. And I think that's completely fine. So that's not going to impact your analysis. It's going to change, or it just requires explanation for the sampling procedure and your population of interest, your sample and your population. Yeah, it's not going to impact the analysis. Yeah, you could form groups based on treatment stage. So if that's what your goal is to look at differences in variables based on treatment stage, then that's what you want to do. You want to treat chemotherapy cycle as an independent variable, potentially. Then you can compare across the different cycles. Yep. Yeah, we're going to stratify the groups. That's completely fine. You're welcome. Glad to help. All right, do we have any other questions? We have a question from Nancy. Does your company offer editing services for dissertations? Yes, we do. So we do have APA specialists at our company. And if you have more questions about that, you can reach out to us. I did close the presentation, but you can either email us at this email address here, info@statisticsolutions.com, or give us a call at 727-442-4290. I'll put those in the chat box. Looks like Melissa just added some web links as well. So you can schedule a free consultation with Janine in which she will walk through your project with you and determine where you need the most assistance. All right, do we have any other questions? Thank you, Sandra. Thanks for joining us. Okay, just to show the two links that are in the presentation, I did put the webinar archive in there. And if you go to our company website, this is statisticsolutions.com. If you click under this drop down for webinars, webinar archive will take you here. And then you can watch videos of all the past presentations that we've done. We do 8 webinars a month covering a variety of topics, so you can check those out. Then you can also view the upcoming webinars. And it looks like the next one we're doing is tomorrow. So my colleague Tom will be doing a presentation on the discussion chapter. Okay, and then next week, my colleague David will be doing a quantitative methodology chapter. And so that'll be a great one to join. If you join tonight, then that would probably be another good one. to join because he will cover data analysis plans again. So kind of figuring out what analyses you need to run, but he'll also cover the research design and the population. He'll probably discuss e-power selection of what instruments you should use and data collection procedures. That's one I would recommend checking out as well. Yep, I'll put it in the chat box. And so that one, the first one is for upcoming webinars, and the next one for future, or I'm sorry, the next one is for the webinar archive for past webinars that we've done. All right, do we have any other questions? You're welcome, Sung-Sun. Thanks for joining us. Any questions about research questions and determining what analysis you need to select? All right, I don't think we have any additional questions, but thanks for joining us, everyone. Come join us for the future webinars that we will be conducting, and let us know if you have any questions. Have a great evening.